All right, ladies and gentlemen, let's do this. Here's what we're going to do. We're going to use this good old pencil right here, this Dixon Ticonderoga number 2. Whatever basic information is in our heads about trigonometry and this piece of paper. We're going to make a t-chart, and we're going to graph y equals the tangent of x. Now, there's a couple of things that are kind of strange about graphing y equals the tangent of x, and one of those issues is that, well, sine and cosine are these smooth and continuous waves that go everywhere, but the graph of tangent is not continuous. It's got breaks in it. So I'll explain why. You'll see why in a minute. But you know how with cosine we started at 0 for x, and same with sine, we start at 0. But for tangent we start at negative 90. Yeah, that's kind of weird, right? So here's what we're going to do. Here's how we're going to start this. I'm going to put 90 over here. I'm going to leave some room in there for 30 and 60. We'll get to that in just a second, okay? So here in just a minute, you'll see why this works. Now, this is actually one entire cycle for tangent. So it has a period of 180. Whereas for sine and cosine, the period was 360 degrees, right? So we're going to go ahead and we're going to find out these coordinates. We're going to find out these values. Here's y is equal to the tangent of x. This is x degrees, right? Here's 90. And we'll say this is negative 90, and of course 0 is there. 45, negative 45. Okay? So that's where our graph's going to fit. That's going to be one period. Now, just like before, this is going to be copied and repeated all over the place. Okay? So now, let's talk about the unit circle. See if we can figure out these values from what we remember about the unit circle. Let's talk about quadrants 1 and 2. You'll see why 1 and 2 here in just a minute. So our unit circle, here's half of our unit circle. The unit circle has a radius of 1, and it lies on the center. Sorry, obviously you cannot write coordinates and speak at the same time. So this is 0 degrees, right? I look like googly eyes. That's 0 degrees. This is 90 degrees. This is 270 degrees, which is the same as negative 90 degrees. Do you see? Now, thing you might not remember, the tangent of an angle is the same as sine of that angle divided by cosine of that angle. That's true. So like, for example, the reason we picked 45 is because the coordinates at 45 are really simple. The coordinate at 45, they're both the same value, square root of 2 over the square root of 2, right? So here's what we're saying. We're saying that the tangent of 45 degrees is equal to the sine of 45 divided by the cosine of 45. Do you see? Now, the sine of 45, square root of 2 over 2, cosine of 45, same exact number, that's 1. Do you see? So that's in the first quadrant. Here both numbers are positive. Here in the fourth quadrant, at negative 45 degrees, right, we have the same exact thing, except the x is positive and the y is negative. Do you see? So we have negative 1 for the tangent of negative 45 degrees. So here we have negative 1, and for 45 we have 1. Yeah? So if this is 1 and this is negative 1, I've got a dot here, right? Oops. At negative 45, at negative 1 right here, and then right here. Yeah? Now at 0, let's talk about what happens at 0. At 0, what we have, our coordinate is 1, 0. That's cosine, sine. Yeah? And tangent is sine over cosine. So it's on the coordinate plane, on the unit circle, it's y over x. So here, that's 0 over 1. Well, that's just equal to 0. No problems there. And maybe you can see now where the trouble is going to come in. Trouble comes in at 90 and negative 90. Let's look at 90 degrees. At 90 degrees, on the unit circle, the coordinate is 0, 1. So the cosine of 90 is 0, and the sine of 90 is 1. Tangent is sine over cosine, or y over x. So that's 1 over 0. That's not a number. There's nothing times 0 that equals 1. So that does not exist. That's why on a calculator, if you were to plug in, hey, what's the tangent of 90 degrees, it yells at you. It says we have a domain error. So this doesn't exist. And the same thing here. At negative 90, at 270 degrees, we have 0 comma negative 1. It's the same issue. 1, negative 1 divided by 0, also not a number. There's nothing times 0 that equals negative 1. It's not a number. So, yeah, that's why we have those two do not exists. So what we end up with is these vertical lines, these vertical dotted lines, they're called asymptotes. They're actually not part of the graph. A graph's a picture of all the answers. So like every time you put a dot on your graph, like right here, this coordinate says for y equals tangent of x, if x is negative 45, then tangent of that number is negative 1. So every coordinate you should be able to plug in for x and y in the solution. These don't exist. These are the things that are missing from the domain. And so our graph is going to be in between there. Now it looks almost like we could have a straight line right there, but it's actually going to be really, really curved. And to kind of see that, let's go ahead and explore two more numbers. Let's explore 30 and 60. Let's see how 30 and 60 go. Okay. Now at 30 degrees, I don't know if you remember, but at 30 degrees, the coordinate on the unit circle is the square root of 3 over 2 for x and 1/2 for y. Yeah, so this is y, this is x. And we know that the tangent of 30 degrees is going to be that y over x. And I know this is confusing because this is from the unit circle, not this right here. It's not talking about this graph, okay? So here, the tangent of 30 is going to be y over x, so it's going to be 1/2 over the square root of 3 over 2. We can simplify that. Let's see. And then we multiply by the reciprocal, yes? So the 2's reduced, and you're left with 1 over the square root of 3. You can rationalize the denominator, right? You could probably do it in your head. So you get the square root of 3 over 3. Yeah? I think that's like 0.577. Let's find out. Let's do this right here. So if you're learning the unit circle, or any sort of basic math fact, and it's new, you should do all the work on paper and make a guess first, and then use your calculator to verify. So here's what I've got. I got the square root of 3 over 3 is this. So what I'm going to do to verify that, I'm going to go ahead and hit tangent 30 degrees. Ah, good. See, we're good. So 0.577, if this is 1, that's a half. It's a little past half right here. Do you see? Now 60 degrees has the same coordinate, well, the same values, just in opposite positions, right? So this is cosine and this is sine. So if we're going to calculate tangent, it's going to be the square root of 3, which I think is about 1.7 something. So let's find out. Square root of, let's see, square root 3, 1.7, right? And tangent of 60, 1.7. Ah, we're good, do you see? So 60 was 1.7. That's going to be way up here. And we're going to have we're going to have those same values, but in negative over here. So at 30 and at 60. So the way the graph actually looks is, you see this asymptote? You see how it's going down over here? It's decreasing. Over here, it's increasing. As the graph gets closer to that asymptote, it's going to bend down. And it's going to get closer and closer. We'll actually never, ever touch that asymptote. And so the graph's going to look something like this. You see? So as we get closer and closer to 90 degrees, the graph's going to go, the y output is going to get higher and higher. So like if we do x, y, let's do 89, let's do 89.5, let's do 89.8. And we'll see how this works right here. So tangent 89 is all the way up to 57.3. Tangent of 89.5. Wow, 114.6. Tangent of 89.9. 0.8. Wow, all right. Now let's just change that to 9. It's 572, well, 573.0. And then watch, 89.994. 9,000. So the closer you get to 90, the higher the output's going to be. And the closer you get to negative 90, the smaller the value is going to be. So let's do 89.994. Do you see? So that's why our graph looks like this. And if you look on a graphing software, this picture right here is repeated. So we have another 180 degrees, which would be all the way over here at 270. You'd have another vertical asymptote, have one x-intercept within that period, and it would be copied over like that. Same to the left, same to the right. Do you see? So hey, I hope this has been helpful. If it has, please give it a thumbs up. Let me know. Leave me a comment down below. And visit my website, beardedmathman.com. I got all kinds of practice and good information on trigonometry and all kinds of other high school math topics. I hope this has been helpful, and I hope you have a great day. I'll talk to you later.